for the chapter real numbers. Practice set 2.1 I studied in the previous video. So we are going to study the rational number and real numbers. Rational number and real numbers. What are the rational, irrational numbers? The number which is not rational is called as the irrational number. Irrational number. When we consider all the numbers, then those are the real numbers. But when we eliminate the rational numbers from the set of real numbers, then the remaining numbers or the set of numbers is an irrational number. Set of irrational numbers is denoted by Q complement, Q dash. Q dash means Q is a set of rational number and the set of real number is a universal set. Then Q dash means complement of rational number is Q dash, and that is irrational numbers. The decimal representation of irrational numbers is non-terminating and non-recurring. In last session, we had studied that all those numbers which we can represent in the form of P upon Q, the terminating decimal factors, recurring decimal fractions and recurring decimal fractions are known as the rational numbers. But which numbers are irrational numbers? Those are non-terminating as well as non-recurring decimal fractions are known as irrational numbers. Now, how we can represent the decimal form of irrational number? For that, we consider the example of root 2. Example of square root of 2. In 8th standard, we studied the division method for finding the square root of the given number. The same method is used here to find out the decimal form, or means the square root of 2. We have to take 2 and give the decimal, take the number of zeros and grouping. 2 has a single group and each 2 0 has a group. So 2 is, we have to find a number whose square is 2 or less than 2. Obviously there is 1. 1 is a number whose square is 1, which is less than 2. So we divide by 1. 1 ones are 1, 2 minus 1, 1 is remain. We take the next group, that is 2 zeros. This group is taken here and give the decimal. We add the 1. 1 plus 1 becomes 2. Keep a number after 2 such that by multiplying the same number, the product is 100 or less than 100. And that is obviously when we substitute 4 after 2, then 4 4s are 16, 4 2s are 8 plus 1, 9, 96. So we divided by 4. This 4 is taken here. 100 minus 96, that is 4. We take the next group, that is it becomes 400. We add that 4 plus 4, 8, 2 as it is. Now keep a number so that by multiplying by the same number, the answer should be 400 or less than 400. When we take 1, 1 the 1 8 is our 8 and 1 2 the 2, 281. When we take 2, obviously 2 2 the 4, 400 and this is 162, means 300, 562, that is so greater. So we divide by 1. 1 is taken here. 400 minus 281, that is 190. Take the next group of zeros, it becomes 11,900. So we add the same 281 plus 1, that is 282, and by dividing by 4, okay, it becomes 11,296. We subtract 11,296 from 11,900, that is, this subtraction is 604. So again we add this 4, then what happened? That is becomes 8. 8 plus 2, 2 plus 2, 4. We divide by 2 here, that 4 is taken, this is 4. Again we divide by 2, it becomes, and the subtraction is 3836. When we observe this, the division is non-terminating and there is no any number which is recurring here. This means that the square root of 2 is non-recurring and non-terminating. Hence, the square root of 2 is a irrational number. In this way, we studied how we can represent this, find out the square root of 2. Okay. Now, properties of an irrational numbers. Properties of an irrational number. Suppose R is to be taken as a rational number and R is taken for the irrational number. If the sum of a rational number plus irrational number, it is irrational. One rational number and irrational numbers get added, then the sum is irrational. Similarly, when we subtract any irrational number from rational number, then the subtraction is irrational number. A rational number into irrational number, that is irrational. And rational divided by irrational is also irrational. Means this is the relation between the rational and irrational number, or the operation between rational and irrational. Now, for the operations between two irrational numbers, if two irrational numbers get added or subtracted, then the subtraction or addition should be rational or it may be irrational. It is rational or irrational. Then when two irrational numbers are multiplied each other, then their product should be rational or irrational. Similarly, when they divide, then the division may be also rational or irrational. This is the properties of irrational numbers with their addition, subtraction, multiplication or division that takes place. Then rational plus irrational, that is irrational. Rational minus irrational, irrational. Rational into irrational, irrational. Rational divided by irrational, that is irrational. And when the operation takes place between two irrational numbers, then their result should be rational or irrational. Now, properties of order relation on real numbers. Order relation means their comparison in short, or how we can operate them. Some operations. Suppose A and B are two real numbers, then one and only one of the relation holds good. They have one and only one relation. Which relation is that? Either A and B are equal, or A is less than B, or A is greater than B. Out of these three, only one relation can be held between two real numbers. Any one relation is there in between two real numbers. Second, if A is less than B, then and B is less than C, then what happens? A is also less than C. First is less than second, second is less than third, then first is also less than the third. Third property, if A is less than B, then A plus C is less than B plus C. When we add any number to both the numbers, then their relation remains same. A is less than B, then A plus C is also less than B plus C. Fourth one, if A is less than B and C is greater than 0, then what happens? Then the product of AC is less than BC. The C is greater than 0 means C is positive. Then the relation between AB, that is A is less than B, that holds same. AC is less than BC. But if A is less than B and C is less than 0, C is less than 0 means the C is negative here. Then what happens? AC is greater than BC means the relation get changed. Why? Because C is negative. Okay? Square root of a negative real number is not a real number. Because why? Because there is no any negative square of any number. Means we know that minus 3 square is 9. The square of negative number is positive. So it is not possible to us the square root of any negative number is not a real number. So we will take the practice set 2.2. The first example is, listen properly, show that 4 root 2 is an irrational number. The example is, show that 4 root 2 is an irrational number. Means we want to prove it, this is a irrational number. Suppose, consider that 4 root 2 is not irrational. If it is not irrational, then obviously it is rational. So we consider it 4 root 2 is a rational number. Let us suppose that is a rational number. It is a rational number. If it is a rational number, then obviously we can write it in the form of P upon Q. Suppose that 4 root 2 is a rational number and its value is A upon B. Okay, it is rational. Hence we can write this in the form of numerator and denominator, where B is not equals to 0 and A and B are integers. B are integers. What happened? This 4 is in multiplication to the root 2. This 4 goes in division. Then what happened? Root 2 equals to A upon 4B. A upon 4B. Friends, previously we had studied that root 2 is irrational number and this is rational. Means root 2 is irrational and A upon 4B is rational. Means what happened? RHS is rational number and LHS, which is root 2 and irrational number. One side is rational and another side is irrational. It is possible? Obviously no. Hence this is contradictory. This is contradictory, means this provides the contradiction to our supposition. Which is our supposition? 4 root 2 is rational number. If it is contradictory, means our supposition is wrong. Our supposition is wrong. Which is our supposition? 4 root 2 is a rational number. This supposition is wrong. So what is correct? 4 root 2 is irrational. We had supposed that it is rational, but it is wrong. Hence 4 root 2 is irrational number. So our supposition what is our supposition? That is 4 root 2 is a rational number. It is a rational number. Is wrong. So what is correct? Therefore 4 root 2 is irrational. What is the correct statement? 4 root 2 is irrational. Okay, hence 4 root 2 is irrational number. Okay, we had considered it is rational, but from this statement it is clear that our supposition is wrong. If it is wrong, then what is correct? 4 root 2 is an irrational number. It is proved. The same example, that is second example, prove that, example second is, prove that 3 root 5 is an irrational number. 3 root 5 is an irrational number. The steps are same. Let us suppose that three plus root 5 is a rational number. It is a rational number. If it is irrational number, then what happen? 3 plus root 5 equals to a by b, where b is not equals to 0 and a, b are integers. A and b are integers. So what happen? Root 5 equals to a upon b minus 3. This is irrational number and this is rational. Root 5 is irrational number, a upon b minus 3 is rational number. Means for this statement, LHS of this statement is irrational and RHS of this statement is rational. LHS, which is root 5, is irrational and RHS, which is AB minus 3, is rational. Hence, this is contradictory. Means our supposition, which is our supposition? 3 plus root 5 is rational number is wrong. 3 plus root 5 is a rational number, it is wrong. So, what is correct? 3 plus root 5 is an irrational number. It is an irrational number. You have to write the statement similar to this. RHS is rational and LHS is irrational. This is contradictory. Okay. Question number 3 from the practice set 2.2. Question 3 is, write any 3 rational numbers between the 2 numbers. This is a common statement and we have to take the example between them, that is minus 2.3 and minus 2.33. We know that if any 2 numbers are there on a number line, suppose this is A and B, when we want the midpoint of this segment AB, then we have to add, means we have to take their average, A plus B upon 2. Then what happens? We get this number. In this way, we take the average of these two, then we get the number between them. Okay, similar. So 1 by 2 into bracket minus 2.3 plus minus 2.33 is equals to 1 by 2 as it is in bracket minus 2.3 as it is plus into minus minus 2.33. So they have the same sign. What happen? 1 by 2 into bracket minus 2.3 minus 2.33, the addition is minus 4.63, minus 4.63. So when we divide by 2, then what happen? Minus as it is, 2 2 is 4, 2 3 is 6, 2 1 is 2. What happen? 1 remain. Take 0, 10. 2 5 is 10. Means the point between minus 2.3 and minus 2.33 is this one. So to find the second number, we take the average of this one with any one of them. So we take for the second, suppose this is first, for second we take 1 by 2 into bracket minus 2.3 plus minus 2.315. Okay, So what happened? 1 by 2 into minus 2.3 minus 2.315. When we add this, 1 by 2 into 4 minus 4.615. When we divide by 2, so what happens? Minus as it is. 2 2 is 4, point 2 3 is 6, 1 is less than 2, so we take 0, 15, 2 7 is 15, 2 7 is 14, again 5. Okay, now take the average of this with this one, then we get the third point. 1 by 2 into bracket minus 2.315 plus minus 2.33. So what happened? 1 by 2 as it is into bracket 2 plus minus 2 to 4.336 314.516. Okay, divided by 2 minus 2.323. Okay, there are 3 points, 3 numbers. Between these two numbers are 1 minus 2.315, second minus 2.3075, and third, that is minus 2.323. So therefore the 3 points between the two numbers minus 2.3 and minus 2.33 are minus 2.315, minus 2.3075, minus 2.323. Okay, the practice set 2.2 is over here.